This lesson will provide an overview of the valence bond theory. When atoms combine to form a covalent bond, two unpaired electrons from the two atoms pair up and are shared by both atoms. In the valence bond theory, we describe these covalent bonds in terms of the overlapping of orbitals. With the valence bond theory, there are two types of bonds that can be formed. First is a sigma bond, which occurs when orbitals overlap on axis. This always occurs in single bonds between atoms. The second type of bond that can be formed is a pi bond. Pi bonds occur when orbitals overlap off axis. Pi bonds are always formed when there are double and triple bonds. Let's take a closer look at what these bonds look like. We'll first use a bond between two hydrogens as an example. Hydrogen has an electron configuration of 1s1. This means that when two hydrogens bond, the bond will occur between two electrons in 1s orbitals. Thus, we'll have an overlap of two 1s orbitals, which will look like this. To describe this, we can say that a sigma bond is formed by the overlap of two 1s orbitals. The shorthand for this is usually written as the sigma symbol followed by a 1s bond. Let's now look at a hydrogen and fluorine bond. Once again, hydrogen's electron configuration is just 1s1. Fluorine's electron configuration, on the other hand, is the same as helium's, followed by 2s2, 2p5. We can break down our 2p5 electrons to show exactly which of the three 2p orbitals the electrons are in. This can be written as 2 electrons in the 2px orbital, 2 in the 2py orbital, and 1 in the 2pz orbital. The choice between x, y, and z doesn't have any significance. But now we can see that the electron in the 2pz orbital will be the one involved in the covalent bond. Thus, our bond will be between an electron in the 1s orbital of hydrogen and an electron from the 2pz orbital of fluorine. The overlap of these two orbitals will look like this. To describe this, we can say a sigma bond is formed from the overlap of 1s and 2pz orbitals. The shorthand notation will look like this. Note that H and F are written to show which orbitals are from which atom. If a fluorine atom were to bond with another fluorine atom instead of hydrogen, we would have the overlapping of two 2pz orbitals, which would look like this. This would be a sigma bond formed from the overlapping of two 2pz orbitals with the following shorthand notation. Let's take a look at one last example of a double bond between two oxygen atoms. Taking a look at oxygen's electron configuration, we can determine that there will be 2 electrons in a 2px orbital, 1 electron in a 2py orbital, and 1 electron in a 2pz orbital. The first bond formed will be between the 2pz electrons of both atoms. The overlap of the two 2pz orbitals will look exactly the same as we saw for fluorine earlier, and will be a sigma bond. The second bond formed between the oxygen atoms will be between the unpaired 2py electrons. The overlap of the 2py orbitals will look like this. As this second bond is off-axis, it's considered a pi bond. As you may have noticed, there is less overlapping between the 2py orbitals than we saw for the 2pz orbitals. This makes pi bonds weaker than sigma bonds. Altogether, we can write the bonding of two oxygen atoms has a sigma bond between two 2pz orbitals plus a pi bond between two 2py orbitals. Remember that all double bonds will be formed from one sigma bond and one weaker pi bond.